Welcome to a brief history of information systems. I'm going to be looking at the time period from the 1940s up until the present, well, and particularly up until the mid-1990s, with a brief touch on what's happened since. But before we can get into that, let me talk a little bit about the background. So in the late 1800s and early 1900s, there was the first really big wave of businesses that sprang into existence. Massive consolidation across many industries. And this largely took place because of the railroads and the advent of telegraph and telephone, which allowed businesses to not only communicate at a distance, but also to transport goods across the country at incredibly low rates. Now, as these first big businesses sprang into existence, they created massive demands for data processing. Now, if you would go back to these early businesses, you would find literally departments that were filled with hundreds of clerks or accountants or data processors, bookkeepers, people to manage all of the information that was being generated from these massive businesses. At the same time, we found many scientific and research organizations that have progressively started using more and more sophisticated mechanical calculating machines. Because let's face it, who wants to sit there and try to do all of our math by hand? So scientists are the same way. They don't want rudimentary tools, to do advanced mathematics. They want a way to automate the process of calculations. So it was designed a lot of the mechanical calculators to do this. And you're getting incredibly sophisticated by this point. We also saw that there's increasing amounts of technologies, including a very important one, a technology that existed for performing Boolean logic. Now, you may not know what Boolean logic even is at this point, and that's okay. But think of it like this. Boolean logic basically allowed mathematics to be married to logic. Now, up until this point, they were usually two separate domains. The fields of logic and the field of mathematics were two completely different fields. Well, there's the guy, the mathematician, Boyle, was the one who really developed this. What we found, though, at this point was that there's a lot of great technologies and a lot of great ideas about how to automate systems, but they weren't put together. And so in order for the computing industry to really evolve and to be created, it needed to combine automation and control systems with the ability to program them, with the ability to do data processing and storage, with the ability to use electronic systems to speed up the process, and to be able to use binary mathematics to do a vast variety of skills that are necessary in today's computing environment. So we have all these ideas that were burning and simmering underneath all this growth in the world, both the Industrial Revolution and at the very tail end of our scientific revolution, that we saw the beginning of the information age. Now, the information age is usually targeted around 1950. Why that date? Well, that's when the first computers were created. It's the first time that more than 50% of our workers were white collar versus blue collar. So if you remember, blue collar is basically people who worked in factories and did a lot of heavy lifting of things. The white collar workers are the people that sat behind desks and worked with information. Now, at first, a lot of these people were clerks, but you had a few lawyers, you had a few accountants, you had a few other people that were white collars. But it was the first time in 1950 where we saw the majority of the workforce were white collar workers. So why 1950? Why did it start there? Well, we saw all this growth going on in business, and we saw this advancement in science and research. We also saw, shortly before 1950, a major event was impacting the world. Think what was going on in the world in the 1940s? Yeah, a little thing called World War II. And World War II is really the impetus that drove a lot of research into the invention of computers. So why was this? Well, during the war, World War II was one of the first wars where the winner, in a big part, it was a race as much of anything as to trying to develop as much advanced technology as quickly as possible in order to win the war. And ultimately, it was won when the United States developed the atomic bomb. And that's pretty much brought the whole thing to a close. Well, along with a lot of this research and development was a lot of scientific research being done and a great need for a lot of processing. So, for example, every time you invent a new bullet for a gun, and this is particularly in artillery, so they had very large shells that they launched, but also had different types of guns. Well, every time they designed a new version of the gun or a new type of the shell, people would have to calculate the distance and the range and how far they'd expect these bullets to go and what would happen at the other end. So that way, on the field, when you're shooting these guns, you don't want to have to try to do a mathematical calculation to figure out how far the bullet's going to go. Instead, you're given a table. And under that table, it'll list, the distance to target, the elevation change, and perhaps even wind speed. And so you can quickly look at this table, calculate what angle to lift the gun to, and then fire it. But they needed somebody to do all these calculations for them. And at the time, before there were mechanical or electronic computers, there were human computers. They actually called them computers. These were people that would compute. And what they did all day was solve these equations. Now, people are notoriously bad at being consistent with math, making small little errors here and there. And so what would really make this process a lot better is if they could automate it such that it would be faster and it'd be more consistently correct. That way they could innovate faster and come up with better guns to win the war. Now, this is important. We don't want, we don't want to be speaking, German today here in the U.S. We kind of like our language, want to keep using it, right? And honestly, the Germans at the time were being pretty much big pricks, and they wanted to destroy us all. So this was important for us. All right. So during that war, there was actually many variations of the computing system that were first created. And here's a short list. Actually, this is the entire list. Not just it is short, but it is the entire list. Starting with Zeus, which is actually a German developed computer, developed in May 1941. Fortunately, the Nazis didn't see much value in it. And so even though this was a fairly advanced programmable computer, it really didn't amount to much. We also saw out of, I believe it was Iowa, the ABC computer, which stands for the Antisoft Berry computer, also developed in 1941. It was binary and it was electronic, but it wasn't programmable. In England, they developed the Colossus Mark I and Mark II, and they used this to help decode some of the encrypted messages that the Germans were sending. It was also binary and also electronic, and could be partially programmable by rewiring. Up at Harvard, they established the Mark I in 1944. It was not binary, it was not electronic, but was programmable through punched paper tape. And then there was the ENIAC, which was developed in the University of Pennsylvania in 1944. Not binary, but it was electronic and was partially programmable through rewiring. And so we see all of these coming together. See, in fact, 4 completely independently developed computers. Now, ENIAC actually borrowed some information from the Mark I and the ABC. They were aware of those two. The other two, the Z3 and the Colossus, Colossus was protected by English security. They did not want anyone knowing that they were developing this. And the Z3 was German, and obviously German wasn't being very open about their research either. The Z3 probably will get the biggest vote for the first to be programmable digital computer ever built. Went at a whopping 4 additions or subtractions per second. Yeah, not very quick. But it did combine Boolean algebra with mechanical switches. So it was all mechanically based, not electronic, but it still could do a lot of the same things that they can do today. Zeus was not directly aware of a guy named Babbage's work, and Babbage is often credited with developing the first diagram for a programmable computer back in the 1800s. It was never actually built, but he had the ideas that spawned a lot of this future development. So what were some of the first issues with these computers? Well, one was making them mechanical versus electronic. Now, there's a built-in speed limitation with mechanical computers. So if you can make something electronic, you automatically get a nice big bump on the speed at which it could process things. And so obviously, even though a lot of these first computers had a lot of mechanical parts to it, there was a natural inclination to try to move to electronic. But what you needed was a certain way to do switches. And switches are basically a way of saying, go this way or that way with the signal or the message. And it allowed you to make Boolean choices, 0 or 1, this way or that way, yes or no, true or false, 0 or 1. The second major issue was whether to use digital versus analog. Now, analog can be very advantageous in certain situations. And a lot of the computers prior to this time were analog. Now, digital is nice in that it's very precise. It's very exact in that you know the precise digit. Analog is very good with working with fuzziness or waves or things that may change rapidly over time, but you don't know which direction. Okay. But what we found is that if you move to digital, you can mimic the analog's ability to fluctuate with waves and signals as you get more precision with your digital calculators. And that's why when we moved from vinyl records, if you guys remember the old-fashioned plastic records, those were all in analog. But when we moved to cassette tapes, those were digital. And CDs and DVDs later. Once you go to digital, then the question is, what is the best way to do calculations in a digital environment? Is it through binary, which means you're working with the ones and zeros, or versus a decimal system, which is what we traditionally use, going from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and having 10 different digits. So 10 digits or 2 digits. Well, when we're working with switches that can either go 0, 1, 0, 1, 0, 1, it seems almost natural to want to use a binary digital system for doing your calculations. Now, here's the interesting thing about mathematics, is that you can do the exact same mathematical calculations with binary and with decimal, and you'll still get the right answers. So it wasn't a limitation of mathematics. It's more of a being able to think in binary terms and binary digits versus thinking in decimal, which is what we're most used to. Once we overcame that limitation and realized what we could do, the natural inclination was to move to binary because of its natural affinity to the digits, to the switches and to Boolean algebra. The next computer issue was making it programmable. So we wanted to make sure that we could change the calculations that we needed that this machine to do. We didn't want to have to be stuck with the same calculation over and over and over again. Now, granted, you can make something that can do the same calculation over and over and over again, which is great for what it's worth. But what happens when you need to do some slight variation of that, or a completely different type of thing. Well, that's where programmability is so infinitely more powerful. So to make a computer that's really useful in multiple different settings, you got to make it programmable. And one of the last issues was actually being able to synchronize these calculations. So being able to make sure that if you send a signal through a set of these switches, that you don't set a second set of signals through until the first set is done. And you have to synchronize it just right so you can use the maximum speed out of all these different switches without sacrificing the precision in the results. So all these issues are big major computer issues that were very early in the development of computers. Now, what's amazing, and I'm going to jump back real quickly to the architecture of the Z3, was what's amazing about the Zeus was that this architecture that they developed ended up being one that's very familiar to a lot of people. Now, if I were to tell you, you look at the center top, it says control unit. That's essentially your CPU. You ever heard of the CPU, the central processing unit? That's it. Okay, and you're going to have various inputs and outputs, like your keyboard is an input, your monitor is an output. Now some monitors are both outputs and inputs because you can touch them and control the screen that way. The punch tape reader and the punch tape today is essentially just memory. But the punch tape oftentimes contained programs. So you'd write a program and you'd send it to your control unit. The program would be stored in some sort of storage device. And it's read into your control unit. The control unit has to send things into a certain memory. Now this memory allows you or helps you with your synchronization. It allows you to enter in a set of calculations. It calculates them, puts them in the memory, and then the punch tape tells you to grab some information from memory and to do some new things. This allows you to gain a great deal of flexibility in how you write your programs. And this architecture is one of the basic architectures that's still in use today. So here's a picture of the Harvard Mark I. It used punched tape. So if you can imagine a long piece of paper tape with a bunch of holes in it. The holes were entered in a certain order, in a certain distance from each other, and that order told the machine what to do. The tape was used for programming, and electrical mechanical switches were used for the logic. It was a huge freaking machine. I mean, it took up an entire floor. I mean, look at that picture. Whew, that baby's huge, right? Well, ENIAC, which was created based on a lot of the Harvard knowledge, but went beyond that, was the first one developed that, I don't rephrase that, the ENIAC was sometimes largely credited as being the first programmable electronic computer. Its ancestor, the UNIVAC, was the first one built off the ENIAC platform that was sold for commercial purposes. So in 1951 it came out, and its first installation is in the U.S. Census Bureau. The U.S. Census Bureau had to deal with lots and lots of data processing, so this was a very good fit for them. It was used in 1952 to predict the elections. And there was an interesting story with this because the UNIVAC actually calculated the winner after just 1% of the voting was finished. The UNIVAC predicted Eisenhower's going to win. But the people who got the answer didn't believe it. So guess what they did? They fudged the answer and published the fudged answer. However, the real winner was Eisenhower. And when the news came out that the UNIVAC actually did predict the right person, it kind of created a little buzz around this. UNIVAC actually is a pretty powerful machine and can do a heck of a lot of stuff. Well, IBM finally got into the game in 1952. So IBM at this time created, so before IBM created the mainframe, they created a lot of accounting machines for large businesses. Their primary customers were these large Fortune 500 companies, and they built accounting machines that essentially allowed them to do a lot of business calculations. Now, they also had a scientific branch that allowed them to do advanced scientific calculations as well. And IBM finally started consolidating some of these and started including some programmability features in the early 1950s. And actually competed fairly successfully with them. Now, with all this, so the mechanical switches were the early creations for electromechanical switches, which were often actually used in telephones as well. But the first electronic device that was used to improve the speed of computers was the vacuum tubes. Now, vacuum tubes were nice and that accomplished what needed to be done, but they were limited in that they were very large and expensive and used lots of energy and were prone to burn out quickly. So it was a good start. But if you can imagine having 50,000 light bulbs, essentially, a vacuum tube isn't exactly a light bulb, but it helps get the idea across. Imagine 50,000 light bulbs all burning on the system. And the system can only continue working if all the bulbs are lit. Well, what's going to happen every time one of those bulbs burns out? The machine stops. You have to replace it and then restart from the beginning of your calculations. So, yeah, it was not good. And this was 70 some odd years ago, where technology, although they had some good technology at the time, isn't where it is today. And so, yes, things did burn out much quicker than they do today. So, fortunately, in 1947, the transistor was invented. Now, a transistor was built on semiconducting material. One of the most popular ones used is silicon. So when you hear the term the Silicon Valley, what it refers to is actually the industry that developed in semiconducting material, silicon, that built transistors. And there was actually a fair number of companies in Silicon Valley that built transistors and sold them. When you put a bunch of transistors together, you can create switches that could be used for logical circuits. It didn't take long for the big companies to realize this and to completely transform their vacuum tube devices into transistor devices. IBM was the first, and in their IBM 7090 was one of the first fully transistorized mainframes ever created. 50,000 transistors plus extremely fast magnetic core storage, at least fast for that day. Only cost just shy of $3 million and rented for $63,000 a month. Not very many businesses use these things. You basically had to be a very large business to be able to afford it. But if you could then cut, let's say, 1,000 clerks that were working in your company, you might just very well save that money. Now, in order to compete with IBM, it was more than just to create a computer, right? Because IBM did a lot more than just build hardware. They also built the software, the peripherals, like a printer. They also fed in, punch cards. Well, IBM also created those punch cards. And so they had card readers that could then read the information off the cards. Well, you could put a whole program and the data on these cards, feed it into a reader. The reader would put it into the mainframe would process it, and then print it out. Not to mention that IBM had an incredible marketing program already developed and had entry into a whole host of companies throughout the world, large companies, through their continued relationships with them. But here's a picture of what the IBM 7090 looked like. Okay, and not all of it was the computer. You can see the center console with the chair sitting in front of it. On the left, you can probably make out the printer sitting there, and all around you see these wheels. Well, that's where they had magnetic tape that had a lot of storage, and lots and lots and lots of storage. But this entire room worked together to give you the mainframe capabilities. So, like I said, a lot of these early mainframes were programmed with punch cards. And I heard from my own dad, who got his degree in mathematics, but did a lot of programming back when he got his college degree back in the 1970s, that they still use punch cards for programming. And it was a real pain because you could be walking to the mainframe facility with your stack of punch cards, and if you dropped those cards, they would scatter, and you would have to spend hours trying to rearrange the cards into the correct order in order for your program to work. Well, all the programmers knew this, and they hated it. So they ended up starting creating something called a language that you could type in messages into the mainframe and avoid the entire punch cards altogether. You could type it in using a keyboard into some sort of monitor. At the time, they were called terminals, that would then connect to the mainframe, and the mainframe would be able to process it. So it's two of the most early programming languages are FORTRAN and COBOL, and they're still in use today. They still haven't completely gone away. COBOL is especially some mainframe computers still use COBOL in them, so there still needs to be COBOL programmers who can work with it. So IBM, because of its huge marketing and its great ability to innovate on the mainframe, quickly became the largest mainframe marketer. In 1964, it had over 70% of the market. At the time, it was called IBM and the Seven Dwarfs, because the other 7 companies that created mainframes were Univac, General Electric, Honeywell, RCA, Control Data Corporation, National Cash Register, and Burroughs Corporation. So how did IBM get there so quickly? In part, it gained a lot of early experience building computers with 2 projects, one called Sage and the other called SABRE. Sage was one of our advanced radar warning systems that our military developed to find airplanes flying in. Now, you gotta understand, this is the beginning of the Cold War. We were worried that Russia might send in a plane loaded with a nuclear missile, and we needed to be able to be notified immediately whenever these planes started coming in. And so SAGE was the computing system designed to handle that real-time processing of hundreds of radars searching for planes. The other one was SABRE. Now, SABRE was also airline-related. It came about because of a conversation between an American Airline executive and an IBM executive. You have to understand, at this time in the 1950s, the airline registration system was all based upon paper. And so, if you had an airplane that you needed to book up, so you want to make reservations, how are you going to do this on paper? Well, basically you need a big room and then people that call into phones, and then you have some clerks who can check to see if a particular plane at a particular time has been reserved or not. Now, if you can imagine, this is going to require a big room with all the possible flights leaving that airline on the wall all the way around it, and clerks running to and fro from these registration lists in order to check to see if there's any open seats on a particular flight. It was not sustainable as the airline was growing dramatically during this time period. And so they eventually developed, through a partnership from American Airlines and IBM, they developed SABRE system, which was the first online reservation system. And when I say online, I just should say it was the first computer-based reservation system. It wasn't online in the sense that it was connected to the internet because there was no internet yet. So IBM was the leader. But they also realized very quickly that the way they were developing their systems was not sustainable. So they really started thinking hard about, all right, we need to be able to use, they wanted to have a line of computers for varying different sizes of organizations and various different needs. But they didn't want to have to create the same piece of software, or a different piece, I'm sorry, they didn't want to create a different piece of software for all these. In other words, they wanted to be able to create, let's say, a registration system that would work on their largest computer and their smallest computer. But in order to do that, they needed some intermediary. Otherwise, they'd have to rewrite their entire piece of software every single time. And this is kind of where the idea of an operating system came in. IBM saw that they wanted to have a line of computers of large to small, but they wanted to be able to write software that would work on all of them. So in order to overcome this, IBM essentially created their System 360, which allowed them to have one operating system that worked on their largest to their smallest mainframe, but allowed them to create software that would work on all of these. Well, with the coming of age of transistors, they started realizing we could put transistors all together and create something called integrated circuits. And the integrated circuits allowed them to put tons and tons of transistors into one chip and allowed you to create smaller and smaller computers. So by the end of the 1960s, we had what was called minicomputers that were being developed. And these were more desk-sized computers that didn't require an entire room to power and run, and were becoming a little bit more useful for things like engineering departments, and tended to be a bit more specialized. Once the integrated circuit was invented, minicomputers started competing more directly with mainframe applications, though, because it allowed them to do more and more processing that the mainframes generally required. We also found during the 1960s that all this computing power and computing processing was great, but what happened when the computer was sitting idle, was doing nothing? And that was a great waste of resources. And so they wanted to be able to connect these computers together so that way they could share those resources. So let's say the people out on the East Coast, when they get up in the morning, it's 8 a.m. there, but on the West Coast, it's only 5 a.m. Well, those computers on the West Coast may not be being used. So the people on the East Coast are like, well, why can't we use some of that processing power? We'll pay you for it, but we want access. So this idea of sharing networks and being able to share your data and information and the computing processing power spawned the idea of creating a network that connected together multiple different computers. ARPANET was one of the first and ended up developing in what today has become the internet. All right, moving on. So the third generation was created of these integrated circuits, which were awesome, but they said, well, if we can put some transistors on a chip, why can't we put enough transistors on a chip so that it could essentially run as a complete processor, that central control unit? And so the microprocessor was born by Intel in 1969. Now, the first version wasn't very good. It didn't sell very well. So they said, all right, we need to expand on this, make it better. So their next version, the 8008, came into market in 1972. And various different companies started creating these new microcomputers using the 8008 as the central processing unit. They didn't sell very well. It wasn't until Intel came up with their next version, the 8080, which overcame many of the limitations built in the 8008. It was capable of 46,000 kilobytes of memory and was used in the Altair 8800, the first PC commercial success. In fact, there was one advertisement in Popular Electronics that gave this company over $250,000 in orders. Okay, that's not $1 million company, but it did prove a point that there was a lot of people out there interested in developing computers as a hobby. And this thing sold for like $500. It wasn't very expensive. So just imagine that. So $250,000, $500. That's several $1,000s worth of, or over 500 orders for these things, right? Is that my math right? That was a lot. All right. Around the same time, in fact, Wozniak and Jobs were good buddies in high school. Well, I shouldn't say that. Wozniak was already graduated from the same high school that Jobs went to. So they went to the same high school, but they graduated at different times. But they became good friends. They were both electronic geeks. They both loved computing. Wozniak was probably by far the more superior engineer, but Jobs had his own special interest in marketing and business. But they realized very quickly that they could develop their own personal computer that was a little bit slicker than this Altair. I mean, if you look at the Altair, look at the front dashboard. You had to program it by flipping switches. Now, who wants to sit there and spend all their day flipping switches in order to program something? Even if you're not a programmer, you know that sounds very tedious. So these guys are like, well, let's create a keyboard that could type information in and display it on a monitor. We'll create the circuit board and we'll sell it. So Wozniak developed a personal computer using not the Intel's microprocessor, but it was actually Motorola's WDC6502 microprocessor. It was cheaper, which, for better or worse, is what they just went with. And with Jobs' help, they marketed his personal computer in 1976 as the Apple I for $666. It wasn't until they developed the Apple II that they really achieved lasting success. And they actually were able to convince a lot of big names. So they got a guy who could help them with their marketing. They got some people to help with financing. And were able to launch the Apple II to huge fanfare, huge success, which rocketed the whole company into the stratosphere that everybody knows today. It wasn't the cheapest thing on the market. What they did well was they made it look very slick. They had a lot of good expandability features, and they had some advanced graphics. So it just looked good, and that's what people wanted. If you're going to buy this and put it in your home, you want something that you can tinker with, sure, but you also want something that, as computing technologies advance, you can change your computer and make it better. If it already comes with good graphics, though, that makes it a great tool to have in the house to play around with. In fact, Wozniak was a huge gamer. In fact, when he developed the Apple II, one of his requirements was he wanted to make it cool enough that he could play games on. And so he did. Now, IBM eventually became aware of what was going on at Apple. They weren't ignorant of it. They saw the growth in the microcomputer environment, the PC computer, and they said, we need to do the same thing. Otherwise, we're losing out on this huge, huge market share. Now, IBM also realized, though, that working with small desktop computers was not their specialty. They are used to working with very large-scale machines. And so after one aborted effort, they decided to outsource pretty much the entire development of the personal computer that they were going to sell. That included even the operating system. So IBM, when they first developed their personal computer that went on sale in 1981, actually used Microsoft's MS-DOS as the operating system. Now, Microsoft at this time was just a small software company, like there was thousands of small software companies. The one thing that made Microsoft successful, though, was this deal with IBM. But because IBM outsourced pretty much everything that went into this, Other companies were able to copy IBM's design. And in fact, they did, and created a lot of what were at the then called the clones. But it includes companies like Hewlett-Packard, Compaq, Dell, Gateway Computer, and a host of others. But Microsoft, prior to landing the contract with IBM, was a small software firm. It wasn't until they hit this contract that their royalties from the operating system basically funneled or funded all of Microsoft's growth throughout the 80s and 90s. It was their cash cow. It was their thing that really helped them become a huge success. Now, they created a lot of software throughout the 80s and 90s, and a lot of them flopped. But because they had so much money coming from the operating system, they were able to keep perfecting the software until they were able to come up with things like Microsoft Office, which Office is a compilation of software that they put together, their spreadsheet, their database, their word processing, their presentation software. All of those weren't that great when they first came out with them, but after many years of improving upon them, it actually became a fairly good product. It was really the spreadsheet application, more than anything else, that got the PC into the offices. Right? Otherwise, it would have just been sitting in the homes as a nice little fun thing to play with, like a gaming machine. But the spreadsheet started allowing accountants and financial planners and managers to start doing some real calculations very quickly and a great deal of flexibility. Businessmen no longer were dependent on the mainframe time to schedule running analyses. And VisiCalc, which was written and sold with the Apple II computer in 1979, was one of these first spreadsheets that did the job well. Well, these mainframe computers and even the early microcomputers were very limited in their display. Now, if you go back, you click on this page and look at that screen, green and black, boring, boring, boring. It did allow you to enter the data and do some calculations, but it was not something that was very interesting or easy to work with. So to improve the interactivity of these machines required a different way of thinking about computers. Actually, and Apple was the first one to really master this when they developed the Macintosh. Now, the Macintosh was actually based upon some research done at the Xerox company, but allowed you to create a graphical interface accessible with a mouse. So you could use so this is where the mouse first came from, was Apple created it and allowed you to use a mouse, move it around, click on things, and now you have the ability to, to click and open things visually versus trying to type stuff in through a keyboard. Microsoft followed with Windows 1.0 in 1985. Apple sued them over patent infringement, but lost the case. Eventually, it created a bit more animosity between the two because Microsoft was also developing its software for the Apple. So that included Microsoft Office, which Apple sold, or they could sell on their product. All right, other things going on in the industry at the time. Well, portability was also very important. It's great to have these big monstrous machines that sit on your desk that can do these processing. But after a while, you want to be able to carry it with you. The first transportable computer was called the Osborne in 1981. It was really sucky. Tandy Radio Shack developed the TRS-80 Model 100 in 1983 as the first laptop computer. It was big. It was massive. It really wasn't something you would want to put on your lap, at least not for very long. But it was marketed as a laptop computer. In 1989, Casio developed their BOSS, which was so small that it was practically a PDA, which is a personal digital assistant. Apple Newton released it in 1993, the first system to use personal digital assistant in its marketing campaign. And then smartphones originated in 1993 as well with IBM's Simon phone. So it contained a calendar, address book, world clock, calculator, note page, email, fax, and games. But that's just about it. So what else was going on? Well, there was also a big push for integration. So at this time, we have all these different computing environments being created, all these small computers being installed in businesses. Well, they wanted to be able to start working together better. And one way that happened was through creating networks. As I mentioned, ARPANET was originally a university research network, started in 1969 with 4 nodes, later connected with business networks such as BITNET. In 1991, the World Wide Web was created. So the internet had been around for years before the World Wide Web. They are 2 separate things, and we'll talk more about that more later. But the World Wide Web, the graphical user interface you're used to going to every single day, was just created. And commercial traffic was finally allowed on the internet. I shouldn't say free commercial traffic. Also starting in the 1990s, another push for integration occurred in databases. And we'll talk a lot more about this throughout the semester, and something called enterprise resource planning. So rather than having all these different databases for all these different things going on in the organization, they said, well, why don't we put these together? It was in massive projects in a lot of these corporate data centers, but tended to produce some really good results. So in the last 10 years, so we're going to kind of jump ahead here, we see this relentless drive towards modularization, integration of technologies, enhanced interactivity, and more intelligent software powered by enhanced modeling techniques, miniaturization, and continuous connectivity. Whew. What is that putting us towards now? Well, we'll spend the rest of the semester really digging into this last 10 years. But new technologies that are now gaining prominence include social networks, multi-touch screens, enhanced search technologies, and even 3D printing. So what we need to try to do is start gaining an understanding of all this changing that's going on within the industry. So we've seen in the last 70 years, computers have radically changed the business environment. And it's going to continue to radically change. The question is not so much what do we have now, but how can we think about computers so that going into the future, we can make sense of this new technology. Because at this point, businesses simply cannot compete effectively without information systems. And these information systems are changing at a furious pace. There's so rapid of innovation going on. Some newer technologies that have not had time to fully mature, there's going to be newer technologies that you have not even heard of yet that are going to be coming out in the next 5, 10 years, and 20 years, and 30 years. And many of you will still be working 30 years from now, 40 years from now, maybe even 50 years from now. If you can imagine what has changed in the past 70 years and where we're going to be in the next 70 years, it is amazing. Because that mainframe that was created back in the 1940s is today an incredibly weak machine compared to my little bitty smartphone that I have sitting on my desk next to me. My smartphone is better than the computers they had in the 70s, and probably even better than the computers they had in the 80s. So, as businessmen and businesswomen going out into the industry, you must be able to understand the key concepts behind these technologies in order to evaluate newer technologies as they come, and in order to understand new business opportunities as they come, and how technology can help facilitate that. And so the whole point of teaching a class, such as in management information systems, is to help you to understand that stuff. And so that is why I teach this class, and why I've made this video. I hope you've enjoyed this brief history of computers. If you need to get in touch with me, you can reach me online at professordrake.com or by email at drakejo@ecu.edu. Thank you.